Okay, good morning again to everyone. Welcome to the second week of our course, Automating GIS-processes 1 or GeoPython, depending on what version of course you are enrolled to. And thanks for filling the poll. You can still continue doing so, but I can start going through your answers, and this is a very good recap of what we have done in the first week. For those of you who might have missed the lecture, and I know there have been quite a few late registrations, so this is a nice recap of what we did last week. We started with the basic Python coding. So we learned some basic functions of Python, like how to print or how to check the type of data. We learned how to work with variables, which is a simple topic, but very, very fundamental to programming. We did some very basic Python math. In the lecture part at the beginning, we learned a bit about computers. So hopefully after that, what programs do, what coding does, makes a bit more sense to all of us. We learned a bit of Python syntax, and that is going to continue for the next 5-6 weeks. We learned how to automate things, and this is just the beginning. When we learned, for example, how to write for loops, when we learned how to make loops in general, then we can see how effective programming is for automating things. We saw how we can use a repository, but this is a topic that we are going to cover in more depth today. We start working with GitHub, and that's actually the second part of lecture today. In the first part, we will do our usual coding with Python, and then we continue with GitHub today. And for some of you, everything was already familiar. We started from very basic, so if you have had any experience with programming and specifically Python, there is no surprise that the topics were already familiar to you. But we are going to learn new stuff all the time. So this is a recap of what we did last week. Let's check the other question. So some problems understanding the course environment, just because there are so many all new to me, and just difficulty getting started with the actual programming, since I couldn't quite figure out how to get there, understood the actual. Okay, so this is something that happens almost every year. There are many pieces, and at first it's a bit confusing. But it always gets better after like second, third week. Like today we start talking about GitHub. Like last week we just kind of forced it to you for submitting your assignment. But this week we are going to talk about it, so it starts to make sense. And many things we do are around GitHub, so after learning GitHub it makes more sense. The environment came up a second time here, and it is going to get easier. And this NOPE is so user-friendly compared to like using any other environment for programming, Python programming, that once you get used to it, I'm sure you will like it. And actually many students who take this course and continue using programming in their thesis, in their work, I've seen that they continue using Jupyter Lab because it is a very nice environment. But needs time. The program stopped working at some point, and we just had to restart it. That happens quite a lot with programming, especially if you're running something complicated, if you have an error, if it's something heavy, you might run out of memory, you have to restart the kernel, and that is something that I will try to show you today. Some of you had problem opening NOPE and ended up using Binder. Binder works as nicely, it's a bit slower, but NOPE usually works fine, and it's hosted by CSC, so if they have a problem, then you might have problem opening it. Some of you didn't have any problem so far. How do I verify return exercise 1? So if you go to the same repository, you should see your file. So if you have uploaded the file and now go to the repository, you should see the file. If it is there, if you can see it, we can see it. So that's easy. And sorry for the problem we had during the first week with submissions. Like, I'm going to talk about GitHub Classroom today in the second part, but we are using GitHub Classroom, which is a service provided by GitHub, and it builds on GitHub for education. So what we do, we put the assignments there, and once you accept the assignment, it clones or makes a copy of the repository for you and gives you admin rights. So something is going wrong with their service. So when you clone, the clone is created, but it doesn't give you the admin rights. So that's the problem many of you had. And it was happening in like 70% of cases, so 30% of you got lucky maybe. So yeah, I hope they resolve it. If not, we can still continue manually giving you the rights. Shouldn't stop us from doing what we want to do. But yeah, it's more or less it seems that everything is clear. There are no big problems for first week. And as I said, I promise everything will start to get more clear as we progress. So let's start with our lesson for today. If you haven't already opened Noppe, now is a good time to do that. You probably remember how to do this. But I'm going to start from the course's website, giving you an overview of what we are going to learn today. So we are going to continue learning the basics of Python. So you get a bit more confident in programming. You will get a bit more comfortable, of course, every week. We will get to learn more about the course environment, and particularly about Git and GitHub. So that's, I would say, that's one of the main parts of the lesson today. But in the first part, before looking at GitHub, we will work with Python, and we cover some topics. We continue working with conducting basic data type conversions. This is something we already did a bit last week. We continue with that. And one of the main things we are learning today is a new data type called lists. So we'll start working with lists, and we are going to use them a lot in your work when you are doing anything with Python, especially regarding data sets. Then related to lists, we are going to learn about index values and learn how they work. Then we have the GitHub part of the lesson, and that's it. And once we are done with the lecture later today, or most likely tomorrow, you will have the lesson uploaded here, as we are recording it now. So, basic elements of Python. Let's go to our Jupyter Notebook environment, Noppe. So this is something that we are going to do every week. So I opened it already, and I navigated to my work folder. This one. Remember that this is the persistent directory, so anything you save outside there, it will be erased every time. I have a couple of folders here. You don't have them. I've been trying things out. But you have these notebooks from last week. Let's go inside that directory. So what we do every week, probably on Sunday before the lecture, we add the materials for the week. So I've done this yesterday, and I'm going to pull the latest changes. So you probably have made some changes last week because you were typing things. Do not push them. Do not commit it to the repository. Let's just get the latest materials. So there's an orange circle there telling you that there are new stuff. So let's just do that, pull, change it. And I'm going to talk about GitHub, so pull, push, clone. These terms will make sense. So successfully pulled. Now I go back to my directory. I should be able to see the L2, lesson 2 folder. So did we all manage to do that? If you try, and this is something that is going to happen a lot during this course, if you make changes to, well, we made changes. We were typing here last week. If you try to submit that to GitHub, there will be conflicts. But we are going to talk about conflicts later. But now it seems that everyone managed to do this, so that's good. Let's open this second file here, Python basic elements. So far we have learned a bit about variables, their values, and data types in the previous lesson. Now we will continue with a new data type that is called list. So list is also one of those reserved terms in Python that, for example, you cannot use for naming a variable. So what is a list? It's a collection data type. So instead of having an individual value in a list, you have a collection of values. So you can imagine if you have a lot of data, you have a lot of readings, whatever the data is about, it's nice to have a collection of the variables. Instead of defining individual variables for storing like temperatures of different days, it's handy to just have a collection data type where you put everything. So all temperature readings from Kumpula from all September. So this is basically what a collection is. In Python, we have a number of collection type data types, collection data types. We are going to work with some of them. For example, we are going to work with tuples. We are working with dictionaries later. So you will learn more of them. But list is one of the most basic ones, and we use it quite a lot. To explore the topic of lists, to practice with lists, we will be using data related to FMI, observation stations. So we will be working with temperatures recorded from different stations in Finland. Yeah, and that's what we will be doing. Okay, so we'll start creating a list. And once we work with it a bit, you will see how it looks like and how you can use it, and it makes more sense. So I have already typed this in, so you don't have to type it. So I have a number of station names. So this is how you define a list. So you have a name for it. It's a variable. It's the same as what we did last week. You can name it whatever. So in this case, we are naming it station underscore name. So it's the name of some stations where we have temperatures from around Helsinki. So this is how you define it. You use a square bracket and you put the values. So it can be as many values as you need. And they are separated by a comma in between. So it essentially becomes just one variable, but inside it you have here 4 text or characters or character values. So I'm going to run this. So now the list is defined. In order to see the contents of my list, I'm going to write the name of the variable and just run the cell. Remember, you can run the cell with Control-Enter. So now you see that the contents of the list I just defined I printed out. So it's one variable, but it's holding 4 values at this moment. And they're separated by comma, and that square bracket is a sign that it's a list. And they are within single quotation marks because they are strings. And we learned about a string, integer, float last week. So that's the data type for each individual item we have in our list. So you probably remember that we used a function, a built-in function called type, for checking the type of data that is stored in our variable. So I'm going to take, and that works pretty much for everything, so I'm going to try it for station names. And it's going to tell me that it's a list. So we have successfully defined our list, and Python is recognizing it as a list, so all good. Okay, so now we are going to see what index values are. Well, when you create a list, you have all the values there. Of course, you want to be able to access those values. How do you access each item? For example, you want to access the 3rd item in your list. All lists in Python are indexed, so so everything is indexed, and you can use that index to address any of the variables, to change the value, to read the value, or do anything that you need to do with that item in the list. So let's start, and this is how you would read one item, for example, from your list. So I'm going to use the name of my variable, where I have the lists. And within the square bracket, you can put the number of lists. So I want to access the item in my list that has an index ID of 1. Let's see what we get. So we get Helsinki Kaisaniemi. And if you look at the list we just defined, so the order matters in a list, so because they're indexed. So you can see that we printed out the 2nd item. So actually the item with index 1 is the 2nd item in the list. And the reason is that indexing of lists in Python starts from 0. So if you want to access the very first item in your list, you have to access index 0. So this first item is 0, Kaisa name is 1, 2, 3. So Kumpula in this case is index 3. So just remember, indexing in lists in Python starts from 0. So they're integers, but they start from 0. Okay, so with that said, if I want to access the very first station name, I have to access the value that is at index 0. So remember, it starts from 0. And now it works. Yeah, this is quite simple, but some of you might be more comfortable remembering things if they are a bit more visual. So remember, it starts from 0. So if you want a hamburger, imagine you have a list of different food items. For example, it's a machine. It's a system you have made for people can just order the food themselves. You might end up using a list. In the list, you have the name of different food items. And in this case, just remember that it starts from 0. So if you have hamburger as the first item on the list, then you have to type in 0 to get hamburger. So if you make a mistake, you may end up with something else. So it's very useful very often to get the number of items that you have in a list. So sometimes you just want to know how many data items you have in the data, in your data in the list. But sometimes later on we will create a for loop. For instance, it goes through the list time, like through each item and, for example, does a calculation. So it's useful to know how many items you have in the list when you're creating the for loop, for instance. And for that, there is a very useful function in Python. And that is len. Len is short for length, and the input you provide is the name of the list for which you want to get the number of the count, the count of the items. So station underscore names. I have a typo here. So when I use len, I get the number of items, and it's not a surprise that we had 4 items in our list, and we get 4 as the output. Okay, let's try one thing. We have 4 items. This is a common mistake. You have 4 items in your list. You confirmed it with the len function. Now you might make this mistake. If you forget that the index values actually start from 0, a common mistake is to just try to access the very last item in your list like this. So you just might think that, okay, I have 4 items. I want the last item. I just provide 4 as the index value. And if you run this, you will get a error that you will see quite often when working with lists. So it's telling you list index out of range. And we know why. Because the index value starts from 0, like I said many times already. So there is no item with the index 4 right now. If you add another item, then you will have index 4. But now, because it starts at 0, it ends at 3. You have only 4 items. So remember, this is a common mistake. If something is out of your range, this is the kind of error that you will receive from Python, an index error. So errors are annoying, especially when you're working on your bigger project, and for your final assignments, you're getting these errors. But they're very useful. They're very informative, and they tell you what's wrong. So now you can, with an index error, now you know what you mean, what it means, so you know how to solve the problem. So let's Let's print the name of the index, the stations again to remember what we have there, and then we will continue from there. So there is one trick in Python if you want to access the very last item in your list. Of course, if you know the index, now what is the last item? Do you remember? What is the index of our last item? It's a 3. So now you know, because we are working with a small list. But if it was bigger and you just wanted to get the very last output, the very last item, there's a trick in Python for that. So station underline names, if you provide -1 as the index, so it starts reading from the very end of the list. So you can imagine it continues. So -1 is the very last item in your list, and -2 is the second last, -3 is the third last. So that's how it works. So now with -1 I got Helsinki Kumpula, which is correct. It's the very last item in my list. So as I said, you can just keep counting. So it makes sense that at some point the first item and last item, well, are the same. So if I access the station names -4, it's essentially the same as index 0. So it's the very first item in my list, counting from them. So this can be useful depending on what you're doing. And you can get the same kind of error if you exceed the index. So if you go with station names, and if I provide -5 as the index value, I'm going to get an index error because it's out of range. Because -4 is already my first item, or index 0. So -5 doesn't exist. In count, you get the, we are going to see that later. You count the number of the certain value in your, yeah, but you're going to get. Okay, now we have a very small exercise. Let's spend 30 seconds doing this. Which animal is index -2? And you can already guess from the screen, but you can also write the code, so as practice. So just copy this or type it in, define your list, name cute animals, and then figure out which one is at index -2. I'm pretty sure everyone got it correctly. I defined the list and access the index -2, and it is a kitten. Counting from the very end is the second item. Okay, modifying list values. Sometimes you need to modify the list values. There's an error, or you're just updating the variables, the values you have in your list. So it's a thing that you might need from time to time. And the good news is that the lists are mutable items in mutable data types in Python. So mutable means that you can change the value. We have some collections, for example, when we are working with tuples, and those of you who continue in the second course, for example, you will see that when doing GIS, the coordinates are recorded as tuples. So you have X and Y, and that's not mutable. So you cannot change the coordinates. You can redefine the whole thing, but you cannot alter a value. But lists are not like that. So you can just edit. If you have item 2, like item 1 is Kumpula, you can just change it to Kaisaniemi. So you can, there's no limitation with that. But you will see, for example, with tuples that we will work with later, you cannot change the values so easily. So now let's start, let's define a new list called station types. The code is already typed in. And we have the same value repeated there. So we have 4 times saying weather stations. Not the most informative list, but we are going to continue working with that. So now we are going to just change. Imagine you have a reading coming from one of your weather stations and you want to put the temperature there, or you want to put the name of the station there. So this is how you would change the value. So let's change the value for station types 2. So I'm going to access that item in my list. So station underscore types, that was the name of my list. And the value I'm going to change is in index 2. So it will be the 3rd item on my list. And this is the value I'm going to store. So I'm going to change weather stations to Mariographs. So this is just an example. You can just change it to anything. You can change it to a number. You can change it to any other word. To make sure that the update was done, I'm going to print again the contents of my list. So now you can see that the list is unchanged except for the 3rd item. Now it has changed into Mariographs. So yeah, so as simple as that. You can just access that item in a certain index, just assign a new value, and that's it. You have an updated list. Data types in a list. One of the benefits of lists is that in one list you can store different data types at the same time. So one of the items can be a string, can be a piece of text. Second item can be an integer. You may have an item that is a float. You might have Boolean values. So you can have different data types in different indices. So that's a very nice thing about lists. You don't need to necessarily create a new list if you want to have numbers and strings all mixed up. Yeah, so let's define a number of variables that we are going to use later to define a new list. So I have a station name. It's Helsinki Kaivopuisto. I'm going to run that. I have a station ID for this station. So I'm going to run that. And then I have the coordinates of it, latitude and longitude. I also run these 2 cells, so the latitude and longitude are stored under this variable, station underscore lat and station underscore lon. And then we have a station type, which is also a string, it's text. So I have now these 5 variables defined. So now everything is typed in. We can just run this cell. But what we are essentially doing, we are using the values stored under these variables to define a list. So previously we have typed in the contents, like you have put 5, you have put Kumpula. But now I'm just using the contents of, so I'm just addressing to this, I'm referring to the variables, and I'm using the value. So let's just run this. And you can see you have created a new list with the values that you have defined up here. And what I'm trying to show you here is that you can have a list with mixed values. So you have string, you have an integer, you have float with decimals, 2 of them, and then you have a string again. So it can be a mixture of data types, all in one list. Yeah, so now we can confirm, check types of the data we have. Let's check the type of, for the list itself. So I'm just going to copy the name so I don't have to type it. If we run this, we can see that it's a list. So it doesn't matter what data types you have inside. It's a list. The next thing I'm going to do, I'm going to check the type for each individual item. So you can access each individual item using the index value, of course. I paste the name of the list, so I don't have to type it again. Now I want to see what data type is my first item on the list. And you can see it's a string. So it's the first value, it's the station name. So it's a list. If you try the same thing for, I'm going to copy this and try it for a different index value. So if I check it for the second item, you can see it's an integer. We had the ID there, so it's an integer. And if you try it for the third item, which is index 2, you can see it's a float. So we had the, was it latitude or longitude? Yeah, we had the latitude, it has decimals, so it's recognized as float. Okay, so now we are going to do a few other things with our lists. First, we are going to learn how to add and remove values from the list. So it's very common that you want to, now we saw how we can alter the contents, like change a value in the list, but what if you want to add a new item or you want to drop one item from the list? Those are pretty easy to do as well, but we haven't seen our list in a while, the one that we defined earlier. So let's just print it again to see the contents. So if you want to drop one item from your list, there's a function for that called del, which is short for delete. So this is how you do it. You provide, of course, the name of the list from which you want to delete something, and you provide the index. So which item in your list you want to remove. So I want to remove the very first item. Now if I print the contents of my list, I can see it has one less item. So the first one was removed using delete function. So this was about removing an item. If you want to add something to your list, so you have 4 stations. What if you have a 5th one and you want to add it there? There's a function, there's a method called append for this purpose. So this is how you append a value to your list. So the list is already defined. So I'm going to write the name of the list, station underscore names. And this is how you access the method, so .append. So first you have the name of the list, then you have .append, and then here you put the value you want to add to your list. So I'm going to add a new station called Helsinki Lighthouse, and it's a text, so I'm going to put it in quotation marks, between quotation marks. Let's also add another item, so station underscore names dot append. Second item I'm adding to my list is Helsinki Malmi Airfield. Helsinki Malmi Airfield. Remember to run the cell, and once you run the cell, let's print the contents of our lists. So now you can see that, okay, we had 4, then remember, we deleted one of the items, we ended up with 3, and now we added 2 other items. So you appended a value, and it goes to the very end of your list. So we have the Helsinki Lighthouse and Helsinki Malmi Airfield which were just added. So removing items, adding items to the list is easy. There are built-in functions and methods for that. So it's a method defined, and this is how you actually are going to see this more often. The more experience you get with Python, you will see that with functions and methods. So a method is accessed like this. So you have a variable, you have a data type, and append is a method, so you access the method with dot. So dot append. But what it does essentially is very similar to what a function does. It just works differently in Python. Do you have any questions to this point? Sorry? Not with delete function. Yeah. You can. We will see something similar later, but you can go through your list, find the item, then you can delete it, but not with delete. Okay, so let's try something new. I'm going to check the number of items I have in my list, and I'm going to store that count in a variable called station name length. And remember, this is how we get the count of items in our list using length function or len function. So now we calculated it, but we have stored it in a variable. So in order to see the value, I'm going to just print the contents. So it's 5. So we have 5 items in our list. So if we check the type of what we just calculated, it's the station name length. It's 5, so it makes sense that the type is an integer. So remember that the method append is for lists. So if you try it on anything else, you will get an error. So for example, now you have an integer stored here, the length. If I try to append something here, you will get an error. So it's an attribute error. Int object has no attribute append, because append is an attribute of lists. So now it might seem obvious, but sometimes you're doing some calculations and your function is supposed to deliver you with a list. But for something goes wrong and you get a number instead, or it's not a list. Then you try to append something, you get the error. Okay, now back to some of the questions some of you asked earlier. So if you want to count the number of times a certain value has repeated in your list, there's a function for that. So there's actually a method for that. So station underscore names, and this is, remember, how we access a method, dot count. And what is the value that you want to search for? So I want to see how many times in my list I have Helsinki Kumpula. So you might have many recordings from Kumpula. You want to see how many times it has repeated them. You can imagine many cases in which you might need something like this. If you run this, you will see number 1 is returned. So it's telling you that in your list you have one time the value Helsinki Kumpula. So this is what you do with count. And remember, count is a method, so you access it with dot. So name of your list, dot, count. With length, it was a function, so it was len. It's just written differently. So now if you want to see where you have the value stored, so for example, back to one of your questions, if you want to delete that item, so for that you need to know which index the value is stored at, and then you use the index to delete it, like we did before. So I use the station, the name of the variable, station underscore names, which is the name of my list, and then using a method called index, you can provide the name of the value for which you want to find the index value for. So Helsinki, and of course it's case sensitive. So Helsinki Kumpula. So it's going to it's telling me that the value Helsinki Kumpula is at index 2. So back to your question, if you want to now delete the value, you just use delete function to delete what you have at index number 2. So what this does, it gives you the very first item with value. So if the Helsinki Kumpula has repeated 10 times in your list, what you get here is just the first occurrence. So later on, when we learn to work with for loops, you can see that you can make a for loop, go through your list and, for example, delete any item that has a... But if you are sure that you have only one, or you just want to remove the first one, then with index you can find where it is. There is another method with lists, and it is called reverse. The reverse method can be used to reverse the order of items. So it just flips the list. So instead of, you can imagine, the order just is reversed. Again, you might need this for something. So station underscore names, and if I reverse it, now I will check the contents to see how it worked. So now we can see it's reversed. So Helsinki Malmi Airfield was our latest addition, so it was at the very end of the list. Now after reversing, it's the first item. So when you are a bit more comfortable with programming and Python, you might make a mistake such as this one. Well, it's a method that does not return anything as a value. And this will make sense to you a bit later on when you work with functions. But this doesn't return any value. It just changes the list that you have. So the list is changed. So be careful with that. It doesn't write it in a new variable. So if you store this in a new variable like this, you're going to just get empty output, because it returns none. So it doesn't return anything, it just changes the list on which you have applied this on. So be careful with that, but we will see examples of this later on. Another method, built-in method for lists in Python is sorting. So you can do it similarly. So station underscore names dot sort. Now I just print the outputs. So I change the order of things. So Helsinki, Kaisaniemi, so it's ascending order. So remember that Python prioritizes like the capital cases. So if you have a capital H and you have another word that starts with A, but it's not capital, then capital appears first. So when when Python is doing the sorting, ascending or descending, capital comes first. But in this case, they were all capital, so it didn't matter. What they do is essentially similar for you, but it's like later on when you learn in Python, learn more Python, you will see they're defined. These are coming as part of like built-in codes and libraries. So in Python, you can define a class that works on a certain data type, in this case list, and for that data type, you can define a method. So it's a function that you can apply to something. So it's like what happens is the same, but because it's defined as a method in a class, you access it differently. So with functions, you put an input, for instance. Remember with length, you put the the name of the leaks inside the parentheses. So if you have len parentheses, then you have the name. With this, you have the name of the list dot method. So you don't put it in the bracket. In the bracket, you might need to provide some other parameters. So what happens is the same, it's just different structures in Python. So this part I'm going to skip now because this we talked about last time, and it's about combining. So you can do this on your own time. So it's about compatibility of different variables. Remember, we talked about this last time. So if you try to add an integer to a text, you get an error. And if you want to do that, then you have to do conversion. Remember? So you can do this on your own, but we talked about this last week. So, yeah, so be careful when you're doing different kinds of operations between different data types. And remember that you can do the conversion easily. So if you have a number, you want to convert it to a text, remember we could just use str, short for a string, then within the parentheses, we had the value. But then we are going to move on to the next thing, which is quite useful and we are going to use quite a lot. So if you scroll down a bit, you get to formatting text and numbers. So Python has changed a lot over years. Of course, now we are working with version 3 point, I don't know, something, 11 or 12. And different features have been introduced. So, like I remember many years ago when I was working with Python, I was using version 2, and some things didn't exist. So one of the new additions, like it's not so new anymore for the last 5 years or so, is the f-string. So it allows you to format the text in a more intuitive way. And now this is something we are going to use a lot. So So we have the value typed in, and I will, as I'm doing this, I will explain so it will be easier. I have the temperature already typed in. I'm going to also define a station name. And it's called Helsinki Kaivopuisto. I'm also going to define a station ID. I'm going to use real values from real data. So this is the ID for the Helsinki Kaivopuisto station. And this is what f-string is. So last week we saw that if you want to combine a text with a number, you could do that. For example, you can say that temperature at Helsinki Kumpula is 12 degrees. So do you remember how we did this last week? So we converted 12 to a string, then you could just add them up. So it's like Helsinki, temperature at Helsinki plus string 12. So you convert them to same format, then you can put them next to each other. But that's not practical. There's a better way of doing that. You might need to do that if you're editing something in your data. There's a better way of combining text and data. For example, if you want to print out a message to the user, then you can use f-string. So this is what we are going to do. So now I'm going to define a new variable. So it's an info text. Imagine you're writing a program for a customer. And if a certain thing happens, if they click a certain button, they're going to have this info text printed to them. Okay. So this is how you define an F string. So normally when you are typing a string, if you just have some message, so for example you want to say the temperature, this is a normal string. But if you, before the quotation mark, if you put an F, you're telling Python that this is an F string. So you will have new possibilities how you can do things here. You can see even the color changes, so Python recognizes that you're doing something different. So what happens when you define a text as an F string, it means that you can pass in variables. So if you want to put the contents of one of your variables inside this string, then you can do it easily here. So the temperature at, so I want to put the contents of this station name. It's a variable I've defined before. So I just want to automatically read the value instead of typing the content. So when you put these curly brackets, you can pass in the name of the variable. So in this case, it's a station underscore name. And this is going to be very useful. The more you use it, the more it will start to make sense. So it's going to read the contents of the station name and put it there for you, whatever format it is. It can be number, it can be text, anything. And then I'm continuing with my text. So remember that I'm still inside the quotation mark, so I'm still writing my info text. I want to also add to the message the station ID, but I don't want to manually type the station ID. And remember, the goal of programming eventually is to automate things, so you don't want to type in things. So I'm just going to put the station underscore ID. Okay. So I'm just saying the temperature at this station with this ID is, then I'm going to type in the temperature. And again, I'm going to access what I have as temperature. One handy thing here when writing F string is that you can format the numbers at the same time. So, and this is how you do it. So with .2f, with f, I'm saying that this number is a float. With 2, I'm saying that print it only up to 2 decimals. So remember, this number, this temperature has like 6, 7 decimals. I don't want it to be all in the message. So 2 decimals are enough for me. So with this .2f, I'm saying float. It's a float, and I need 2 decimals. So this is something that we will be doing a lot. And then I'm going to put the unit, so it's in Celsius. So remember to close the bracket. And then what I'm going to do next is to print the contents to see what I have created just now. So info underscore text. So we were just writing a text message, but we combined variables with text, and that's super useful. Imagine you're working with thousands of values in your data. You're writing a for loop, and you want to print this all the time. These are things we will be doing later. So this is automated because you're not typing in the value, you're just putting the variable, and whatever value the variable is holding in that for loop, in that certain loop, it's going to be printed. So it's perfect for automating. Yeah, so we created a text message. The temperature at Helsinki, Kaivopuisto, with this ID is 18.57 Celsius. So these are F strings, and we are going to use this a lot. And this is the structure of the F string. So it's a string. It can appear anywhere. Here we are using it as a value for a variable. You have the usual quotation mark. You put an F before, so Python knows this is a string. Otherwise, if you put this, Python would just write. It won't load the variable. It will just recognize it as text. This is station name. But now it knows that, okay, this is not text. It's referring to that variable I defined earlier. Yeah, so you wrap it in the curly brackets. And then if you want to do some formatting, for example, you can use dot plus something. And you can check from documentation all the possibilities. But one thing that we will be using a lot is controlling the number of decimals in our float. So 2f is very commonly used in our lessons. So we are not going to go through this, but there used to be older approaches to, like before f-string came, I guess in Python 3, there were older ways of doing this. If you're, and they still work, like this format, dot format, it still works. So if you get your hands on some old code written like, I don't know, 6-7 years ago, you probably see this dot format. So this was a lot less intuitive, but did the same job. If you're curious, and they still work. Also this one with this percentage operator. So you might see them somewhere. Okay, so one more thing we have before we take our break and move on to the second part of today, which is working with GitHub, is working with strings, and this is something that will be useful to you later on, manipulating character strings. So splitting a text. So if you have a long word, like the text that you see on my screen now, stations, Helsinki Kumpel. So you have this text. What if you want to just extract one piece of this text and use it? Remember, the goal here is, this might seem simple, but the goal here is to automate things. Later on, we will have more complex problems, so this automation will be very useful. Okay, so now we start with splitting our strings. So this is the string we have. Let's run this cell so it's defined. So I'm going to store the output in a new variable called splitted. So it's my splitted text. Remember, we just defined a variable called text. And this is how you split text. So using a method called split. The next thing you have to do is to tell Python based on what you want to split text. At which point should I split text? So I'm going to tell Python that, okay, wherever you see this sign, split the text. So it will be before that sign and after that sign. So that's the reference for splitting. So depending on the text, so in this case, I can imagine that the text will be splitted at this point. So let's do this, and at the same time, print the output. So let's see what we get. So what it does, it returns a list to you. That is splitted. So it's like everything before that colon sign. You had stations, and there was the colon sign, and then everything after. So you can see even you have a space here after the colon. Even that has appeared here. Because, you know, even space for Python is a space, it's a character. So as you can see, this is a list. I can recognize it by these square brackets and commas in between, but to just be sure, let's check the output. So type splitted is a list. So split function or split method returns a list. And then it's easy because you have a list. You can access different items. So if you want to use the first part, you just use index 0. If you want the second part, then index 1. If you split it more, then you have more indices to use. So I'm going to get the name of the station and store it under station text. So it's splitted. So the second part of splitted. So at index 1. So you just stations text. Yep. Yeah, so you just kept the second part. Second item in your list. These are things that we are going to use later on for different purposes. So you will see the examples of where this can be useful to you. So let's try one more thing. Stations underscore text. So if you have multiple items in your list, this is a way of saying that anything after on item 1. And this is again something we are going to see later. So if you have multiple items, in this case you had just one item, so the output is the same. But if you had imagine item index 1, 2, 3, 4, that one column means that anything after 1. So they will be printed. So it's a useful thing with lists you can do. Another thing you may need to do sometimes is to replace a piece of text in your string. And for that, again, there's a method. So I'm going to create this variable again, stations underscore text underscore text. And this is the method, so replace. And then, of course, what you have to say is that what do you want to replace with what? So I'm going to replace Helsinki with blank. So imagine you have the stations from Helsinki, so they all have Kumpula Helsinki, Kaisaniemi Helsinki. You may not want to have Helsinki repeated every time. So I'm just going to replace it with nothing. So I just put empty quotation mark. So remember, if you put a space in the quotation mark, it's not nothing anymore. It will be replaced with a space. But now it's replaced with nothing. So now I'm going to check the station's text. So you see the name, the word Helsinki has been dropped from the name. So it's not Kaisaniemi Helsinki anymore or Kumpula Helsinki, it's just Kumpula. And this is the last thing we want to do with the strings right now, and that's just changing the string case. This is something you might need to do sometimes, and there are methods for that. So we have .upper, it makes the text uppercase. We have lower, so if you have all in capital, if you put lower, it will make it lowercase. And if you use .capitalize, it will just make the first letters capital. So let's quickly try that and then go for a break. So stations underscore upper. So I'm going to create a new variable and name it the stations upper. And I will use the station.text, what I had earlier, and just make it upper. So I'm going to just copy this and try it for lower, so that I don't have to type. I just replace upper with lower. And again, the same thing. This time I try the capitalize method. Of course, just remember to update the variable name so they don't get overwritten. So this is called lower. This is called capital. Oh. This is capital. Next thing, I want to check the outputs. I'm going to write 3 print functions. In the first one, I'm going to print the contents of this. So I just copy it. Then I'm going to print for lower. Remember to update if you're copy pasting. And then print Okay, so with the upper, you can see it all got uppercase. Then we have the lowercase. For the last one, the first K should be capital, but it's not. I've tried it in an older version. It should work as before. Yeah, but you get the idea. I will check those. Let's go on our break. I will check why I don't get the... Did you get the K capital, any of you? No? Okay, I will check that out if something has changed in new Python. But yeah, let's get back in 10 minutes, then we'll continue with GitHub. Okay, let's continue so we don't run overtime. Okay, so looking back at what we had with the capitalize, well, as you can see, we have a bit of a space at the beginning. That's why capitalize wasn't working. With upper and lower, it's going to just uppercase, make everything uppercase or everything lowercase. But the way how capitalize works, it only makes the first character capital. And because we had a bit of a space, like it was just capitalizing the space. That's why you couldn't see anything. But you can see I tried here, I replaced the spaces with nothing. Then I try this, I get this K capital. So that's why we were not getting the output we wanted. But yeah, before we get to GitHub, quickly something while we are still in Noppe. Let's open the second part, GCP2, Good Coding Practices Part 2. Last week we had the first part. It was about naming variables in a proper way. Today we are talking about code comments and markdown text. So this is something that you should start practicing, and it's very useful for many reasons. Like starting with this course, if you comment your code properly, especially when you are submitting your final project, it will help you. It will help us grading you, because imagine this is a big class. We have like 70, 80 students registered, and we have to go through all the assignments. So if I look at your code, it takes me a few minutes, if not more, to figure out what you are trying to do. But if you put comments and say, okay, this is what I'm trying to calculate, it makes it very easy for me to understand what you are doing. Well, this is just a class, but later on, imagine you're sharing your code with your colleagues, with your classmates, or you develop something in your thesis and you want to reuse it after 2 years. If you haven't left comments, it's going to be very difficult to remember what you mean by different things. So, yeah, so today we are going to look at code comments. You have already seen them in lessons, but we haven't talked about them so much. So we have code comments and markdown text. Yeah, so first, why do we need to make comments? Well, it makes the description easier to understand. So with description, the code is easier to understand for you later or for other people. It makes it easier for people to use your code. It can also help you debug your code. So if it's commented, and imagine, like codes are never 5 lines of code. When you're working on real projects, like hundreds of lines of code. If you have made it comments like here in this part, I'm doing this. Then when you're going back and forth in your script, then it's a bit easier. Yeah, so another good thing is that we are working on Jupyter Notebook, and that's why many people continue working in Jupyter Notebook even after the class. And that's because you can combine text with like images, anything you can put, and at the same time you can have a cell of code. So you can make documentation. So here for yourself you can put a title, like code comments, and then write a bit of text, how you are doing something, and then write the code. So that's a specific to Jupyter Lab. You can put markdown text. But if you are within your code, I guess I mentioned this last week, but you can start a code line with a hashtag sign. So when you put a hashtag sign, anything after it is not read by Python. So you can just write some message for yourself or whoever is reading your code. Another thing that is not, it makes your code messy, but it is something that programmers do all the time, is that you're trying different solutions, but you do not want to delete the old things that didn't work. You just want to disable it and try something else. So very often programmers just comment out that part, but they keep the text so if you want to get back to it. So it's a common practice, but if you overuse it and you don't delete it, of course, at the end you will have a lot of commented code. So it doesn't matter what I have here. I have a hashtag sign, so it's not going to get run. So this is something you see often with programmers doing. So yeah, so if you have line codes, just writing one thing, you can just make a new hashtag on every line to write what you want to write. So this is a good practice. If you have a block of comments, for example, if you want to write this much text, which is useful. For example, if you're defining a function, you can explain what are the inputs, what are the outputs, the parameters. So if you put 3 quotation marks, so you can put a block of text with a quotation mark. Yeah, so this should be closed, but you get the point. Well, it was up there actually. So yeah, so if it is wrapped in 3 quotation marks, you can put anything in between. Of course, you can put on each line a hashtag mark, but this is easier. You can format it a bit. So for longer comments, just use 3 quotation marks. A markdown text, some of you might be familiar with, like the format that we have the contents here. If you double click on this text, this is actually what it is. It's markdown. So markdown, for example, double hashtag is like makes it a title, like this. So it's markdown. We are going to use this later, but if you're working in Jupyter Lab, you can work with the text like this. So I just double click on the cell. In this case, I can see the source code behind the text. So yeah, so we are going to use this a lot. Just remember, it's a good habit to use comments in your code. If you are in Jupyter Lab, make text cells, explain what you're doing in the next step, very similar to what we do in the lessons. Maybe not as detailed, but anyway. If you have blocks of code, use 3 quotation marks. Remember to close it. And if it's just one line of code, use hashtag, sharp sign. Remember also you can do it in front of code. So you can have a piece of code. So I would just make a new cell somewhere. Print hello. So this is a line of code, very simple, but anyway, it's a code. So I can also do a hashtag in front of it. It's not the nicest thing. It's better to put it above it. That's the good practice, but it works. Here you can explain for here, I say hello. So you have the code running, but that after it you have the comments right in front of it. So these are different ways you can add comments. Is this clear? Do you have any questions? Yeah, this is simple and you will hopefully get used to using it. Now let's move on to the next part of our lesson, and that's introduction to version control. So this is a situation that I'm sure most of us have been in. You're working on your exercise, your thesis, whatever document, and you end up with so many copies, and you run out of ideas how to name the file. So very often you have like manuscript, final, then you have another version, it's final 1, final 2, final 3. You just run out of ideas. You have to make so many copies. So imagine in programming, that's terrible, because you're constantly changing your code. It's a big program, you're constantly, so how many copies of the file do you want to keep? It is very difficult. So that's why a smart person has come up with the idea of version controlling, so that you don't have to save your file like this, like final, revision 2, final, with comments. This is something that happens to all of us. So that's the idea behind version control. You're coding, you're changing things all the time, especially if it's a bigger program, then you want to have version control. So if you have messed up something, if something broke, you want to go back, but without having a separate file saved, because it becomes very messy. So that's the idea behind version control. So it just tracks your changes. You don't make a separate copy of the file, it just tracks your changes. It knows that, okay, you added a new line here yesterday, and if that line broke the code, you can just reverse it. So that's why we are using GitHub in this course. Not only for delivering materials, because the repository is useful for us, but also it's good for version control. Yeah, and that's where the idea of, like, there are a few systems for version control, but Git is the most popular one that we are going to also use during this course, and we are going to learn about it today. So Git is a version control software developed back in 2005 by a rather famous Finn, the same guy who developed Linux. So it was made by Linus Torvalds. And yeah, so this is Git. This is software that is open source. Anyone can use. You can use it anywhere. Later on, it became commercialized. So GitHub that we are using is using Git. It just adds a community feature to it. So you see the repository, meaning that they have somewhere hosting files. So with Git, you can use it locally on your own computer, do version control. With GitHub, it's just centralized. Your files are stored somewhere. They have servers. And it's a hub, so I can see your username, we can leave comments, we can work together. So Git is something you just run in your own computer. GitHub is running the same thing, but a website version, hosted version. So that's the idea behind GitHub. You can do version controlling and benefit from everything that comes with GitHub, like social collaborative network. You will see that you can work with others. Like from this week on, you have exercises, and you're doing your exercises with pair. So one of you is doing the work, one of you has created the repository, but you can give access to the other one. So you can both be coding at the same time. And because it's version control, you can see that, okay, your friend, your partner has added this line of code. Everything is tracked. It is good because it supports open source and science. Like a lot of tools that we use, a lot of open software we use are published on GitHub. Probably have, even if you are new to programming, you have heard of the word, or you have at some point accessed something stored on GitHub. So it's very important for open source and science. For documentation, most GitHub repositories come with documentation. For example, this is my exercise 1, and you can see there's text. So this is just an exercise, but imagine if it's a code you're sharing with public. Here you can put documentation. Whoever uses your code can see what you have done. It has online tools. For example, the fact that we have a repository is very nice. Issue tracking, this is something we are not going to use, but if other people are using your code, they notice a problem in your software, they create an issue. They just say, okay, this part is breaking, so someone can fix it. So some basic vocabularies that you are going to hear a lot during this course. So repository. Repository is like, you can think of it as a folder, as a directory. Within that folder, you can have files, you can have other folders. So it's a folder on GitHub that is version controlled. So that's called repository. So it's very similar kind of to a folder you might have on Google Drive or OneDrive, except that it's on GitHub and it's version controlled. So repository, and the repositories can be public, meaning that anyone can access it. It can be private. Like the exercises you make are private. So without us giving you the access, you couldn't see the repository. Then committing. Committing is, to commit is to write or merge the changes made in the working copy back to the repository. So you commit a change. So you add a piece of code, you change something in your software, and then you commit it to the repository. So you can think of it as so everything, not everything is tracked. So it's not that everything you're typing is tracked. You can undo it with the Control Z. It's not like that. You take snapshots of your code. So you made a change, you add a substantial piece of code, and you want to create a snapshot of your code. And that's what you do. You create a commit. So you have a kind of a snapshot of your code, and if something after that breaks, you can get back to any of your previous snapshots. So think of commit as taking a photo of how your code is at that moment. Then we have revision or version, and that's the idea of version control. Every time you commit, you're creating essentially a new version, and you can always go back to one of your earlier versions. Cloning. Cloning is something that you have already heard me saying a few times, and that's what you do when you accept the assignment in GitHub Classroom. So it copies. I have made an original template for the exercise. When you accept it, it clones it. So it just makes a copy for you. So it becomes another repository. It's not just copying files. It makes another repository, which is a clone of the original one. And then pulling and pushing. So when you commit something, well, you have a repository on your computer, or in our case, we are using Noppe, so it's somewhere on CSC server. But you want to send it, you have made a commit, you want to send it to GitHub servers, so I can grade you. because before that it's on your own computer, it's on CSC. So once you do the commit, you have to push. And push means basically pushing your changes to the remote repository. So unless you push something, so there was a question, how do I know I have successfully uploaded? Well, if you upload it directly from GitHub, it's there. But you will see, if you don't push, it doesn't go to internet. So I don't see your exercise. So you make commits. When you are ready, you push it to the repository, it goes to GitHub. And pulling is like synchronizing your local copy, so getting the changes. So remember today, you pulled the latest changes and the new lesson was added. So pulling, like you get things from remote repository to your local, pushing from local to remote. So like, for example, if you think about Google, not Google Docs, it's like pulling and pushing at the same time. Synchronizing is two-way. But in GitHub, it's not two-way. You either pull, get the changes, push, submit the changes. Merge is an integration so you merge different files, and we are not going to work with that so much, so I skip it for now. There are a lot of resources, there are a lot of good videos if you want to learn more about GitHub, because at first it can be confusing. When you get used to it, it's very nice and easy to work with, but at first it's confusing. There are a lot of good materials, so you can check it out. But let's meet Git. So we are going to use GitHub. Like I said, it's not the only service for this, but it's the most popular one. And now we are going to have a tutorial of how to work with this, because you will be doing this every week with your exercises. So we will see how we can clone a repository from GitHub, add our changes, commit our changes, and then push. This is something you will do for your exercises every week, multiple times. So some key concepts. So we have a remote repository, and that's the one that is on GitHub. That's the one I can see. The course assistants can see. Then you have a local repository that can be on your computer or on CSC Noppe. I cannot see your local unless you push. So that's what pulling and pushing is. And when you take a clone, you're basically cloning your remote to local or the opposite. So one thing that we should, I will show this to you in practice soon, but when you are committing, before doing committing, you have to add the changes. So essentially, you're telling GitHub which files to track. You stage, so think of it as this. So you stage the changes, and then you take a snapshot. So by adding, you stage the changes you have made, and then you commit it. Means that you create that screenshot, that snapshot, and then you push it. You send it to the internet, for instance. So remember these terms. Always remember. You make changes, you add it, you commit it, then you push it to the internet if you want. And we will see that in practice. So Git is very powerful. If some of you who are familiar with command line, if you're working on Linux, for example, you can do a lot with Git, like through command line. But there are also user interfaces. Like you can see, I very often use this GitHub desktop. I'm very comfortable with it on Windows. So if you're working locally, you may want to use command line, or you may want to install the software. But now we are in Noppe, and in Noppe, I have installed this plugin for you, so you don't need to do anything. But yeah, so, okay. So in order to be able to work with this, we need to take a few steps. So you need to create a personal access token, and let's do it together now. Because if you are making any changes to a repository that is private, then for that you have to authenticate yourself. And this is the way you authenticate yourself. So we are going to create a personal access token. So let's open our GitHub. And then in the top right corner, you have your picture or some avatar. Then from there, let's go to settings. If you scroll down at the bottom, you will see the developer settings. And on the left, you can see personal access tokens. So we are using the tokens that are the classic version. for our work. Okay, so as you can see, I have some active ones. So this is very important. Don't share it with anyone. If you give your token to anyone, they have control over your account. So I'm going to create a new token, and of course I will delete it right after this because for safety. So if you have this two-factor authentication, it will ask you to authenticate. I have to do it on my phone now. Okay, so this is how you can create a token. Make sure that you're creating a classic token. That's enough for us. You can add a note. You can put a name. What are you making the token for? You can say course GeoPython or anything you want. I write GeoPython temp because I'm going to delete it after this. The validity, of course, it's recommended to have some expiration day. So if you are continuing to use GitHub after this course, or if you're taking the next course, you can put something longer, put it until January or something, so you can use it in the second course. Or if it's only this course, you can put 60 days. Of course, you can choose no expiration, but that's not recommended. Then you have to give a bit of some access, like with this access code, what can the person do? And that is also important. If someone gets their hands on your access code, what can they do? So we only give things that we actually need. We need control over our repositories. Let's also take the admin repo hook. Let's also have delete repo. So you can also delete your repository. So if you want someone gets your token, they can delete your repositories, which is not good. But yeah, let's generate the token. Okay, here the token is displayed, and it's only one time. So next time you open it, it's not there. So if you want, well, you should make a copy of it right now. Just put it in a text file or write it down somewhere, because you cannot see this anymore next time. The code will be active, but you can only view it once. So now you have your own code created. Have to check. Yeah, so it's the first one, the whole group. It's also on the course's website. I can show you from here. Yeah, here. So it's the repo, the whole thing. And then admin repo hook, the whole group. And then delete repo. So did you all get your tokens? So remember, when you're authenticating to your GitHub, anywhere outside the website, because with website you're logging in with your username password. Anywhere else, for authenticating you need your username and token. So your password doesn't help you in CSC Noppe. It's the token. So if it asks you for password, it means token. So, okay, so now we created the token, and what next? Okay, so now I'm going to demonstrate what you will be doing every week for your exercises. So this is exercise 1 from my own test. So when you accepted, all of you have created this. So when you accepted the assignment, you landed on this page. So every week when you are doing your exercise, let's go back to Noppe. So you probably want to create a folder where you do all your exercises. I will create a new folder so I can do this with you. So my exercises. Okay, so I create a new folder. So this is where I will be doing my weekly exercises. From GitHub, if you click on this code button, so last time we were just uploading files. That's not how people use GitHub. So normally it's this way. So from code, you can get a link to your repository. I'm going to copy this link. Then I'm going to, on my notepad, I go to the GitHub plugin on the left. Then I'm going to clone. So you have accepted your assignment. A repository has been created in your name. Now you want to clone it, meaning that you bring it here so you can work on it. So I'm going to clone it. It asks you for the URL you just copied. So I'm going to paste it here. And I'm clicking on clone. It's a private repository, so it doesn't allow me to do anything unless I authenticate. So I'm going to write my GitHub username. You should do the same. And the token is the thing you just created. Let's go get it. So I've just copied from here. So you just paste it here. There is an option to save it temporarily, but it doesn't work. It hasn't worked in years. So if you figure out a way to do this, that would be nice. But it's a bit annoying, but every time you're doing this, it asks for your token. So have it somewhere easy to find. So click OK. Okay, so now it's cloned. So it made a copy of my repository locally here.
For me, it said failed to clone for whatever reason.
Okay. Try again. Did the folder get created or not? Or is it still empty, the folder?
The what?
Did it make you the directory or not at all?
It says failed to clone.
Okay, just refresh the page and see if it works. For others, did it work? Yeah. Okay, so this in exercise 1, it was quite empty. You just had an empty file, markdown file. But from week 2, from this week on, you will have notebooks to work on. You will do exercises. So I will just make some changes, and I will show you how to submit your changes. So imagine this is your assignment. This is where you are working. So I'm inside that folder that I just cloned. I'm just adding something. So this is just some random text. I am testing my exercise. I'm testing GitHub. Okay? So I made some changes. Imagine this is your exercise and you have done some coding. Then I'm saving the change. Let's save it with Control S or from files. So now we want to use the magic of GitHub. I go back to the plugin. Am I going too fast or are you following well?
I'm still troubleshooting
Okay. Let me have a look.
Okay, now it says successful.
Okay, so I guess you're all doing fine. So I made some. You have a problem? Okay. It's not the password, it's the token. You put in a password.
It's token.
It's the token. So we don't need password here at all. Okay, so here it's always your token. Your username, I don't know if it works with email, probably not. Your username and the token. And I guess most of you managed. So let's continue. So I did some changes. I did my homework, my assignment. Then I'm back here. So this is the important part that might be a bit. So there are some temporary files called checkpoint. These are like the cache files, so you don't need to submit those. Just forget about them. But here under changed, GitHub already knows that I have edited this file. So it has tracked my activity. It knows that, okay, you have changed this file. So if you have changed multiple files or you have created a new file, there will be more. Then here you should add. Remember, I told you, add, commit, push. So this is the plus button. You add. So now it's staged. So now you're ready to create that snapshot I told you about. Are we all here now? So just remember, you don't need to do this all the time, but you do a bit of coding. You just take a snapshot, so if something goes wrong, you have a safe copy. So now you have to commit. And for committing, you have to add a message. And people usually put a title and a description. So if you have made some changes like here, I did this. So for example, I said I solved problem number 2. Just for yourself. So later on you can see that, okay, in this commit I have solved problem number 2. You can also add a longer description if you want, but it's not mandatory. Next thing I'm going to do is to commit my change. So it's going to ask you for your name. These are old-fashioned. GitHub was developed in 2005, so it's like it still has things from back then. So it needs your name. You can put whatever. This is just for the records. But don't put, if you are not comfortable with it, don't put your full name or personal information. So I'm just putting my short name, and then you can just write your email. So this is not your GitHub account. This is just for the records, who has made these changes. I put OK. So changes are committed. So remember, if you do this, I'm not going to be able to grade you. You haven't sent it to the internet yet. Everything is on your own computer. So the next thing you have to do is here. You see an orange button here, orange circle. It means that you have some changes that are ready to be pushed. So next I'm going to push this. And here it asks for my username. And then again you need your token for this. Where is my token? So I can save my login temporarily, but it hasn't worked. So anyway, I try. So now it's pushed. So now if I go back to my repository online, you don't have to go there, but to just show you what happened, I can refresh this page. And you can see a track of, like 1 minute ago there was a commit. So that's what I did. You can see a list of commits you have done. So these are all the things I've tested. So the message I typed in appears here. So you can just, you have snapshots of your code at different stages. So it's a good habit to do this regularly, but not after each line of code. But whenever you make a substantial progress, create a snapshot. Okay, so yeah, we did all this. Yeah, for those of you, as I mentioned already, yeah, this hasn't worked, but if you want, you can try. From command line, you can try to save your Git credentials, but somehow CST was erasing the information every time. But you can try it. Maybe it works this year. We already tried pushing. We try pulling every time we start a new lesson, so that we practice. And as I said, Git is very powerful if you use command line. So you know that you can, in Noppe, you can just start a new command line from here. So if you're comfortable with Linux, you can just use Git as here. So you can just git clone and put the URL here. So you can do everything from here as well. But you don't have to, and you can easily use the plugin. yeah, so a bunch of information about Git and how to use it from command line, but you don't need it unless you want to try. And that's it. So everyone is using Git properly now. So it worked well. So one thing that you are going to run into many times is conflicts. So imagine if you have changed something on your computer, on your laptop, then you go home, you try something on your other computer, and then there are suddenly 2 changes. So it's good to always pull the latest changes so you know what everyone else has done, or yourself on other computers, other sessions. Then change. Because if there are 2 changes at the same time, then there's a conflict. So GitHub gets confused that, okay, there are 2 changes, what should I do? So every time you start your work, it's good to refresh, like pull the latest changes, especially if you're working in a pair, because the other person might have worked. So pull their latest changes, have the most up-to-date version to work with. Otherwise, there might be conflicts and they're annoying. I'm sure we are going to see that next week, and then we can see together how to fix them. But next thing I want to show you is GitHub Classroom. I know it didn't make a very good first impression because it's crashing. It's not working well now, but hopefully they will get it fixed. I already saw there were discussions online. They know the problem exists, so I'm confident they fix it quickly. But yeah, for each class, for each week, like here, we have something like this, except the GitHub Classroom. So what it does, and this is something you tried, it creates it clones a new repository for you. You get the link here, then you click on the link, I land here. So I can just copy this link, take it to CSCNOPE, do my work, and when I'm done, I just push the changes. So one thing I would like to tell you is that we have an auto-grading system. So the first week it was a different kind of exercise. We will go through them manually. But from week 2, we have an auto-grading system. So of course we go through every assignment ourselves, me and assistants. But a bulk part of your grading is automatically done. And if there are issues, we go through them, we fix the problem. So if the bot is not doing a great job, don't worry. We will still check. And this is the first year. From like last years, we had a different system. So when the assignment was over and everyone has submitted, me or David just pushed the button and we ran the auto-grading system. This year we have a different one. And it runs every time you push a change to your repository, the auto-grader will run. It gives you feedback. So you get immediate feedback. So you have to push. So you add, you commit, you push. It takes a few minutes, depending on how complex the exercise is, to do the auto-grading. Then you get feedback, and I will show you where that feedback appears. So if you go to GitHub, and this is my exercise 2, what you will be working on this week, there will be a pull request up here. There's a pull request called feedback. And inside here, there are some comments. So great job. With the latest commit and push, your solution for the exercise has gotten 3 out of 8. And these are things you can improve. So you get some feedback. And we only look at your final version. So don't be scared of pushing many times. So you can just push to see if you have solved the problem correctly or not, or to get feedback. So you can do this as many times as you want to get. So every time you push, you get a new comment here. So you have to try it a couple of times. This is the first time 3 weeks ago. Again 4 days ago. So the more time, as many times as you try, you get new feedback. So this is how it works. This is the first time we are running this, so I'm sure there will be issues. The grader might not be smart enough, you might miss a point. Yeah. So one thing is that don't worry, we will check them still, each one of them. And the second thing is that I have made a new channel on Discord. So if you see things out of place, like the bot is behaving weirdly, it will be very helpful for us if you write it down in the channel. So next year we know what things have gone wrong. So we would very much appreciate it. So in Discord there is a dedicated channel for this. I guess I named it auto-grading feedback or something like that. So if there is something off, just write it there and we try to get it fixed probably for next year. But yeah, probably there will be things that are not perfect, but hopefully this helps you. So this is a different system. Now you get immediate feedback. So I would like to also see how is your learning experience. Does it help you that you get immediate feedback, or do you prefer to just get the feedback at the very end? But this is a trial. Let's see how it works out. Yeah, so a bit of information about the auto-grading. yeah, about the pair programming. So pair programming is actually a concept in programming. It's not our invention only for this course. So in agile programming, which is a style of programming, programmers are familiar with it, they have the concept of pair programming. So there is one person typing the code, and there is someone sitting next to you or looking over your shoulder and just making sure so you have like two pairs of eyes looking at the code. One person is the driver, and one person is just the observer. So this is the same concept we are using in this course. So most of you are working in pairs, so everyone has a partner unless there were a few of you who didn't want or couldn't work in pairs. Otherwise, you all have pairs. And each week, I'm going to share an Excel sheet with you very soon, probably tomorrow, and you will see which group you are in and who is your partner. So if you had said who your partner is, then we have just used the same information. Each week in the Excel sheet that I will share with you, there is a column called driver. And your name, in front of your name, you can see that you are the driver for 2, 4, 6, and your partner is driver for 3, 5, 7. This is the number of exercise. So if in each week that you are a driver, the driver has to submit the assignment. The other partner doesn't have to. Only the driver. So we don't look at the other repository. You can do it if you want, you can practice, but we only grade the driver of the week. So every week, make sure, check who is the driver, and only the driver clones the assignment and does the work. As I said, in GitHub, you can give access to people. So if you create this repository and you want to work together with your partner, from settings, you can go to collaborators and teams. So here you can add people. So if you ask the username, the Git username of your partner, you can add them. So they will have access. You can code at the same time. Just remember, try not to run into conflicts. When you open a session, just pull the latest changes. So if both of you have made changes at the same time, it can get tricky. Yeah. But yeah, what we expect is that the driver has submitted the assignment. So you work together, of course, you solve the problem, but only one of you, who is the driver, submits the assignment. So that's how we will do from this week on. Until the final assignment, which is an individual assignment, then you all do it individually. Yeah, so a bit about the pair programming, why pairs. There's a bit of information. The concept comes from this. There's a driver who concentrates on the work, and there's a navigator who tells you, okay, if you have a typo, if you have so it just oversees the work. And this changes every week. So one week you are the driver, the other week your partner. So you both get the experience to be the driver or the navigator. Yeah, so what we are hoping is that you work together and you apply this concept. It's not that one week you do the assignment, the other week I do it. So each week you should do it together. And that's what we hope you would do. Yeah, so as I said, only the driver gets graded, but you both get the grade. Yeah, and you can add the person as a collaborator.
So does the Excel sheet already exist?
No, it will come probably tomorrow. Okay. Later today or tomorrow. So probably later today. Because we have been transferring the information from Discord. One of the assistants has done it, so we have to compile the Excel and just put it for you. But probably later tonight, late evening, it comes. Yeah, then you will see your partner and you will see who is the driver. You can start your work. Okay, is everything clear? Do you see you're ready to do the GitHub work and assignment? And if there are issues, a reminder, on Thursdays, Fridays, we have the help sessions exactly for this. So if you run into a problem, go to help sessions. We have the Discord. We are quite reachable there. And about that problem, I don't know if they have solved the problem. At least we have had it until yesterday, that you create a repository, but you don't get admin rights. So it will be very helpful for us and for you if you create the clone soon. If you start doing it on Sunday and you get the error, we may not be able to respond to you as quickly as possible. So if all of you create the repository today or tomorrow, then it will be easy. We just fix the problem for all of you at once. Yeah, but hopefully they will solve the problem. But that's all. We were efficient today, so we can finish here. And let's meet next week. Same place, same time.